Let us go over the first method to solve linear systems, the substitution method. The substitution method consists basically of 4 steps. Solve one of the equations for one of the unknown variables. Substitute this result in the other equation. Solve this new equation. And substitute the result into the equation we got from step 1. This method is quite useful if step 1 is not too complicated. In particular, if there are no fractions involved in step 1, we are typically okay to use the substitution method. Let's illustrate this with the examples on page 29. Question 1. Solve 2x minus 3y is negative 4 and 5x plus y is 7. We use the substitution method. It should be clear that it is the easiest to solve the second equation for y, as this will not involve fractions. So 5x plus y is 7. We can solve for y by moving 5x to the right. We subtract 5x from both sides. Y is 7 minus 5x. We substitute this result into the first equation and solve for x. 2x minus 3y is negative 4. Now we replace y by 7 minus 5x. Be careful to use parentheses. Next we FOIL out the parentheses. Be careful to distribute the negative sign. We simplify by collecting alike terms. And now we move the 21 to the right by adding 21 to both sides. And finally, we can solve for x by dividing both sides by 17 and simplifying. We find x is equal to 1. Substituting this result into the equation for y, we find y is 7 minus 5x. We replace x by 1. 7 minus 5 times 1, and we find 2. Now remember that the solution of a system of equations is a couple. So be careful to make sure that x is in the first coordinate and that y is the second coordinate. So the solution is the couple 1, 2. Question 2. Solve 2x minus 4y is 5. 5x plus 3y is 6. We use the substitution method. This time there is no easy choice. No matter which equation we solve for any of the two variables, we will end up using fractions. Let's say that we solve the first equation for x. So we need to isolate x, so we move 4y to the right by adding 4y to both sides. We isolate x by dividing both sides by 2. We split and simplify. X is 2y plus 5 over 2. We substitute this result into the second equation and solve for y. 5x plus 3y is 6. We replace x by 2y plus 5 over 2. We FOIL out the parentheses and simplify. We can already collect the alike terms, 10y plus 3y, and we simplify 5 times 5 over 2. Next we move the 25 over 2 to the right hand side by subtracting 25 over 2 from both sides. Now we simplify the right hand side by putting everything on common denominator, which is 2. Finally, we simplify and we find 13y is negative 13 over 2. To solve for y, we divide both sides by 13. If you have problems at this point, it is probably because you did not recognize that dividing by 13 is the same as dividing by the fraction 13 over 1. How do we divide one fraction by another fraction? By multiplying by the reciprocal fraction. Now we can simplify and we find y is equal to negative a half. Substituting this result into into the equation for x, we find x is 2y plus 5 halves. We replace y by negative 1 half. We FOIL this out, put everything on common denominator, and find that x is 3 halves. Again, the solution is a couple xy, so the solution in this case is the couple 3 halves, negative 1 half. Question 3. Solve the system x minus 2y is 4 and 2x plus 5 is 4y. We use the substitution method. We solve the first equation for x. We move 2y to the right hand side by adding 2y to both sides. We find x is 4 plus 2y. We substitute this result into the second equation and solve for y. So 2x plus 5 is 4y. We replace x by 4 plus 2y. We FOIL this out and we simplify by collecting alike terms. Now we subtract 4y from both sides and we end up with a very weird equation. 13 is equal to 0. Note that solving this last equation for y means finding all real numbers y such that 13 is equal to 0. Since it is never true that 13 is equal to 0, there are no such numbers y. So there are no solutions. This is an example of an inconsistent system, and so there are no solutions. Question 4. Solve the system y is 4 minus 2x and 2y plus 4x is 8. We use the substitution method. The first equation is already solved for y. Y is 4 minus 2x. We substitute this result into the second equation and solve for x. 2y plus 4x is 8, and we replace y by 4 minus 2x. We FOIL out and simplify by collecting alike terms. We end up with another weird equation. 8 is equal to 8. Notice that solving this last equation for x means finding all real numbers x such that 8 is equal to 8. Since it is always true that 8 is equal to 8, we get that x can be any real number. Y, however, is determined by x, since y is 4 minus 2x. This is an example of a consistent and dependent system. Writing down the solutions, since there are infinitely many, is a little more tricky. We get that the solution is the set of all couples of the form x, 4 minus 2x, where x can be any real number.